And hello, welcome everyone to this video. In this video, I just want before I start, just want to make a comment, or rather correction. Okay, that we actually have a ToUnit method right here. Okay, the Fahrenheit thing has actually a ToUnit method, or actually most of our units have a ToUnit method, so it can lessen the pain of unit conversion. So let's say you have this freezing point of water. Okay, let me undo that. Okay, undo. Okay, .NET test. Okay, this one I'll deal with later. Okay, so what we have is the freezing point of water, 32 degrees Fahrenheit, right here under the freezing water to string. Okay, so actually if you want to change the unit to Fahrenheit, you can actually use this ToUnit what do you call that, method. Okay, so I'm going to do that. Okay, so here console.write line freezing point water dot ToUnit, and then what's the unit here? I'll use temperature unit dot SI. No, I don't want SI anymore. Rankine. Okay, rankine. Let's see whether this works. If not, I'll have to take a look again. Okay, rankine is not a member of temperature unit. Right, let's go and see what the units are. Engineering units, base units, temperature Enum.cs. Okay, it's degree rankine. Okay, so let's do degree rankine. Okay, back. Alright, insert degree. Okay, there you go. Of course, here we go. Look at this degree rankine now. Okay, so let's print it again, just to see what happens. Did we change this whole object to a .rankine, or does it just return? Does this method return a new object? Okay, freezing point water. Okay. Okay, we still have the original 32 degrees Fahrenheit. So actually this ToUnit thing doesn't change the object itself. It just returns an object. So let's check out the ToUnit what do you call that? ToUnit. Yep. So what does it do? It returns a new temperature object and gives the value as a selected unit. Okay, so this is the ToUnit function, and it does unit conversion for us. Okay, so it's get value as selected unit.unit. Okay, and then the selected unit is, yeah, so this selected unit is what we pass into here. Okay, temperature unit.degree rankine. Okay, get value as this selected unit, and then we have this selected unit thing here. Now this thing does not, okay, it may not necessarily work for the base unit thing. So if you take a look here, ToUnit, there's no ToUnit method for BaseUnit.cs. If you actually try and check everything here, there's no unit thing here. However, there is a UnitCheck thing here, which is pretty useful if you want to use some base units. Okay, this is a method that we can actually use a lot. Okay, this UnitCheck method. Okay, so let's show you the UnitCheck method. Okay, yeah, we'll show you the UnitCheck method in context of what we are trying to do. So first, what are we trying to do? We are trying to do some simple calculations, as in we have this correlation here, CP equals to A plus bt plus ct squared plus dt cubed plus et to the fourth. Okay, so right, so I have this function I want to use, the a, b, c, d's and e. So let me do cp equals nothing first, and console.write line cp. Okay, I want to delete that value of cp. Okay, and then of course, obviously it won't print anything, which is good. Now we can start calculating. Okay, so let's dim T1 as temperature. T1 equals to new temperature. Let's give it maybe 373 is boiling point of water, and then what, temperature unit dot si. Okay, so that's what we have. We can actually console, so write line T1. So this is the temperature we will use. Okay, this is 373K. Okay, so let's actually do the calculation. CP equals to A plus B times T1 plus C times T1 dot power 2 plus D times T1 dot power 3 plus E times T1 dot power 4. Okay, console.write line cp. Okay, let's see whether this works. Okay, so we do have our value, and this is basically how we deal with these unknown units. Okay, at least make new units for ourselves, and we are able to get things checked out. Okay, now let's see what happens. Let's see what happens when we give this the wrong dimensions. For example, e, if you take t to the power 7, for example. Okay, let's see what will happen. Okay, it will give a wrong unit exception, trying to do blah blah blah, cannot add two different units. So this is a very good thing about the units itself. I have to change this to t to the power 4 in order to get this to work properly. So this thing's very nice for us. Okay, so this heat capacity, this molar heat capacity is being calculated, some random number, and we can see that the unit checks actually checks very much properly. So I'm going to do this try. I'll put the try thing here, and I will go up, yank this whole line, paste it here, tap it in, or shift V. Oops. Okay, that's better. Okay, file down. Okay, catch X as exception. Okay, then let me put here, open a new line, X console.write line exception.message, and then try. Okay, 6 up, and then I will just change this to power 1. So this is purposely try wrong units. Okay. Okay, so you can see that there's an exception, but the test passed because I know there's going to be an exception, and I say that we have a try catch structure right here that deals with this exception without failing the program. Okay, so we cannot add two different units, so that's why we have this exception. We purposely try wrong units. So this is a good check for us. So you can see how this unit system actually works very well. Okay, I did talk about unknown units before. And what is unknown units? Unknown units is basically what goes on behind the scenes. Okay, what goes on behind the scenes. Okay, so unknown unit is a copy of base unit, so that all calculations between two units get converted into an unknown unit. Okay, so what is it actually saying? We go for down. Okay, so let's say you have this b times t1, right? Okay, let's say cp equals alright, dim cp2 as object. Okay, dim cp2 as object. I'm going to make this an object. It can be any object. I can assign any value to it. Okay, the similar thing in C# would be the var in C#. Okay, the var keyword. Okay, this is variables declared at method scope can have an implicit type of variable. So an implicitly type local variable is strongly typed if you have declared the thing itself, but the compiler here determines the type. So the var thing is in C#. Over here is just doing it as an object. It's pretty much similar meaning. Okay, cp2 equals to a plus b times t1. Okay, and then what do we want to do? I want to console.write line cp2.getType. Okay, and let's try. So this is how normally it will work. Okay, see, this type here is an unknown unit. Okay, trying to work with unknown units. Okay, so the thing about unknown units is a little bit tricky. There are a few things you can do with unknown units, a few things you cannot do. Okay, so one thing you can do with unknown units is that you can actually add them together. cp3 equals to cp2 plus cp2, cp3 equals to cp2 plus cp2 times 3. Okay, so we'll try that. These things will work perfectly fine, no exceptions. Okay, however, when you try to do a console write line on an unknown unit, okay, if you try to do a console write line with an unknown unit, okay, that is interesting. You'll have a J per mole per Kelvin right here. Okay, you'll have the nice units actually right here. J per mole per Kelvin. Okay, so this thing you can do with unknown units apparently. In my other computer, I was having problems with this. I don't know why though, but okay, let's get the type of cp3. Okay, cp3 is an unknown unit which you can print. Okay, sometimes when I print unknown unit types, it will just mess up. It will just mess up for some reason. I do not know why that is the case. Okay, but the nice thing about unknown units is that you see, it will print it in a very nice way rather than in the base unit format. Okay, you'll not print it in the base unit format. You'll print it in the very nice comfortable format that you see here, J per mole per Kelvin. All right, so hey, thing about unknown units is that you can actually check the units. Okay, you can actually check the units here. Okay, you can check units with unknown units. Okay. Alright, just pardon me. There's okay. Yeah, you can check units here. So remember over here in the base units, you actually had a unit check thing. It's a static void unit check. So how you can use it is what is it? BaseUnit.UnitCheck. Okay, I can do CP3, CP2. Okay, CP3 and CP. Okay, if this passes, nothing will happen. If it doesn't pass, it will throw an exception called the wrong unit exception. Okay, so this thing actually passes. Now, if you try to give it a wrong unit, okay, CP3 with T1. These are obviously wrong unit. Oops. Let me go back. Insert unit check. Okay, try this. Catch ex as exception and try. Go up. And I will do this console.writeLine x.message. Okay, that's the exception handling. Okay, it will see. This is not a Kelvin as expected. Your unit has a type kg meter square per second square mole Kelvin, right? So this thing here is, of course, they will convert it to a base unit and everything. So that's the thing, right? Okay, so thing about unknown units is that you're not normally you try to not work so much with unknown units. They are pretty much base units, like we've seen before. Base units are these custom units that you see here. Okay, we can actually make a new custom unit called base unit if we don't find it around. Okay, but these unknown units are unknown units are the kind of thing that yeah, we have to be mindful of. Okay, just know that they exist. Okay, they exist. You can do mathematical operations on them. You can do unit checks on them. You can add them to base units. You can subtract them. Yeah, you can add them. You can subtract them. You can do all sorts of things with them. Of course, you should not. Yeah, you should always ensure that the unit types are the same. Okay, what are some of the problems where I have experienced is that I try adding an unknown unit to one of these combined units. Okay, for example, I have this I always like to do specific energy because that's the thing. Okay, heat value specific energy. Okay, 10 up. Okay, okay, dim specific heat value as specific energy. Okay, heat value equals to new specific energy. What do we call that? New specific energy. I'll just put 100 and then specific energy unit.si. Okay, console.writeLine heat value. Okay, so sometimes I do this. Okay, working test. This is called testing unknown units with combined units. Okay, so that's sometimes we have the problem here if we try to do it like manually. Okay, so we have the heat value. Okay, pardon, that's my Instapot. Okay, this is 100 joules per kilogram. Okay, yeah, this is 100 joules per kilogram. Yeah. Okay, so let's say I do this dim specific heat as, I wonder if there's a specific heat unit here. Apparently specific heat here, I think you cannot find specific heat. Okay, it's a power per surface per temperature. Okay, specific entropy, which is joules per kilogram per Kelvin, is kind of similar. Okay, but okay, specific heat has become an alias to specific entropy. It's the same units actually. Okay, it's a new feature, and this thing is of course changing all the time. But okay, never mind. I will just call this dim specific heat as object. Okay. 12 up. Okay, this specific heat as object. What do I do? Specific heat equals to heat value divided by T1, for example. And I will try to console.write line specific heat. Right, let's see whether there's a problem here. Okay. Oh, it says here specific heat is a class type and cannot be used as an expression. Okay. So that's true. Specific heat has become a class type. I cannot just use it. Okay, so I'll just call this CP4. Okay, CP4. 2 down. Change it as well. Oh, right. And I have to spell object here, not obj. Okay, so right, this thing, you can see that this thing is an unknown unit. Okay, you can just print the value out, it's fine. Okay, cp4.type. Yeah, funny, I was actually having a lot of errors trying to get these unknown units to work, but apparently they work. Okay, see, this thing is also an unknown unit. Okay, however, okay, I'm just saying good practice is to always change these unknown units back to base units whenever you can. Okay, okay, change it back to base units whenever you can, and make sure you explicitly specify those base units, like over here. Okay, dim A as base unit. Okay, forward. Okay, back. Unit 5. I'll just call this unit 5. Back. I'll call this unit 5. Unit 5 as a base unit. Okay. 12 up. Okay, I will just delete all of this. Okay, I will try to typecast this unknown. I'll try to typecast this CP4 as a base unit. Okay, let's see what happens. I might get an error. Yes. It says unable to cast the type engineering unknown unit to engineering units base unit. Okay, so converting unknown units to base units may not be always that straightforward. Okay, you cannot just convert an unknown unit to a base unit. You might need to do some checks. Okay, you might need to do some checks. So so let's do converting unknown unit types to base unit. Okay, this is very important. Okay, so what I do first is to specify what kind of unit this unit 5 should have, or rather okay, I dim unit 5 as a base unit. Okay, so before I start, okay, you know that when you want to make new base units right here, you need to supply the value and you need to supply that system of units that that you want, right? So CP is already this base unit. Okay, it is this base unit, and this is how we actually get our unit system about. Okay, CP unit, which is over here. So we'll use the CP base unit system. Okay, CP base unit system to check our units. So you want to check the units of CP4. Okay, base units dot where's that unit check? Yeah, unit check is here. Base unit dot unit check. Okay, unit CP4 and CP. Okay, if nothing goes wrong, then it should be fine. Hey, oh, okay. Yeah, these two are completely different units, unfortunately. Okay. So okay. Yeah, if you it's best to, of course, CP4. Yeah, it's best practice to check the units before we actually start. Okay. So this is meter square per second square, Kelvin. So it's joules per Kelvin. All right. This is CP4 unit. Okay. So if I want to change this to a base unit, oh yeah, never mind. Forget the checking. Okay. If I want to change this to base unit, I'll do this. Unit 5 equals to new base unit. Okay, I will get the value of CP4. How do I get the value of CP4? Usually I'll do CP4.value, but there will be a complaint later, and the unit will be CP4.unit. Okay, and then I can do console write line unit 5. Okay, this is how you change your unknown unit into a base unit. Okay, so all right. Yeah, why did the overload fail? No accessible new can be called without narrowing conversion. Wait, this was supposed to work. Okay. Let's go back. Okay. All right. Let's check this CP4.value first, and then we'll work on that thing later. Okay, go back, insert, comment out. I want to check out the value of CP4. Okay, this is the value of CP4. Okay. Okay, let's try again. Overload resolution failed because no accessible new can be called without a narrowing conversion. Okay. All right. Well, let's see. I want to see what the type of this CP unit is. Okay. Oh, CP unit here is a unit system. I just want to check what this CP4 unit type is. Maybe it's a different type. That's why it's giving me problems. CP4.unit.getType. Okay, 6 down. Okay. Word insert here. Yeah, this is also a unit system. This is very strange. Okay. Yeah, this is unit system. Okay, this. Oopsie. This also here is a unit system. All right. Okay. Oh, right. The thing is that I should not be doing a new here. Should I be doing a new here? Oh yeah, I did a new base unit something. This is an interesting error. Let me change this to specific. Okay, I have no idea what's going on here actually. This should, based on what happened before, technically speaking, this should work. Okay, let me change this just to see whether this is the problem. Di bracket 100 specific energy unit.si. Let's see whether that will work. Whoa. Try again. 100 energy unit.si. Okay. Let me change. I think I'm getting an idea of what's going on. But let me confirm it. Okay, insert here CP unit. Oh, okay. I think I know what's going on. Okay. Now this CP unit right here, is our own custom unit, and it's not found anywhere else within this whole entire GitHub repository. However, when I try to insert this specific unit, energy unit.si, okay, I'll change it here. CRW specific energy unit.si. Okay, this base unit, okay, this base unit has a child class. Okay, this base unit here, okay, this base unit class here is inherited by all the other classes here. So it looks like what's happening is this. If I actually supply a unit system to the base unit that happens to coincide with one of the units within the base units, all these classes here, for example, temperature, or this whatever, brake fuel consumption, all these kind of things, yeah. If I do that, I will get an error. Okay. So if I want to convert it to base unit, okay, let me go back. cp4.value. Okay, cp4.value, and then what I do here is, okay, I need to find the actual base unit that corresponds to cp4. Okay, cp4 is heat value divided by T1, and as we see just now, specific entropy is something of the same unit. Okay, you see this thing, specific heat is an alias. Specific heat is an alias for the specific entropy, so I have to type this thing as a base unit, okay, or combined unit. Okay, if there is no, if this thing isn't what do you call that? If this thing isn't if the unit already exists, don't try to make a new unit. That's what I'm saying. Okay, specific heat, or maybe I can leave this as base unit. I'll call this specific heat. Okay, because hopefully Liskov substitution principle should work. Apparently not. Oh yeah, I'm getting a wrong unit error. I should be getting this specific entropy unit.si. I don't understand what's going on. 135. Oh, maybe the problem is this CP4 value type. Maybe that's the thing. Get type. Yeah, so it's always been problematic for me. This is a double. Okay, I don't understand. Really don't understand what's going on. Okay. Let me delete this DW and I'll just do this here. Unit 5 equals to CP4. Ah, yes. Unable to cast object type of unknown unit to engineering unit specific heat. Ugh. So what's the unit of this? Joules per kg per K. Joules per kg per K. Yeah, this is the same unit. Yeah, so thing is with unknown units it's been very problematic for me, honestly speaking. When you actually have some new units. So working with unknown units has always been tricky. So this is some things you cannot do with unknown units that you can, I guess, do with other quantities. Okay, you will have this typecasting problem. Okay, so I guess the way to work around is this. Okay, dim CP4 value as double. CP4 value equals to CP4 dot value. Dim CP4 unit as unit system. CP4 unit system equals to CP4 dot unit. And then I will change this into new specific heat into CP4 value CP4 unit system. Okay. CP4 unit system is not declared. CP4 unit. Okay. Maybe this is the last one. File down. One more time. Oh, no accessible new can be called with these arguments. Overload resolution failed. Oh, okay. So what is it saying? These constructors right here, the constructor for specific heat cannot take in these sort of values right here. Okay. This has been problematic. Alright, I'll stop here. I'll try to find a way to work with this and then I'll come back to you. Okay, as of now, yeah, just facing problems, not really sure what to do. Okay, bye-bye.